There are places in Egypt where the stone looks almost impossible, not because it is mysterious, but because it is precise. Blocks weighing dozens of tons, fitted together with astonishing accuracy. Granite surfaces polished so smoothly they still reflect light after thousands of years. Cut so straight that modern visitors often struggle to believe they were made with ancient tools. For generations, these structures have sparked debate. How did ancient Egyptian builders achieve this level of precision? What tools did they use? And perhaps most importantly, what does this tell us about the people who built one of history's greatest civilizations? This is not a story about lost civilizations or hidden super technologies. It is a story about engineering, organization, patience, and skill. Because the deeper researchers study ancient Egyptian stonework, the more impressive it becomes. Why Egyptian stonework? Ancient Egypt is famous for scale. The pyramids, the temples, the colossal statues. But size alone is not what continues to fascinate archaeologists and engineers. It is precision. At sites across Egypt, enormous stones were shaped, transported, and aligned with remarkable consistency. And unlike mud brick structures, which were common throughout the ancient world, many Egyptian monuments used hard stone, especially granite. Granite is extremely difficult to work with. Even with modern tools, cutting and shaping it requires significant effort. Yet the Egyptians used it extensively in sarcophagi, temple floors, obelisks, interior chambers, and structural blocks. One of the most famous examples can be found inside the king's chamber of the Great Pyramid of Giza. Massive granite beams weighing dozens of tons were positioned high above the chamber with extraordinary accuracy. The joints between some stones are so tight that a thin blade can barely fit between them. And this raises a natural question. How was this done over 4,500 years ago? The Granite of Aswan. To understand Egyptian precision, researchers first look at the source of the stone itself. Much of Egypt's granite came from quarries near Aswan in southern Egypt. These quarries still contain unfinished blocks and abandoned projects that provide important clues about ancient techniques. One of the most famous examples is the unfinished obelisk. Had it been completed, it would have been one of the largest obelisks ever created. It remains attached to the bedrock today because cracks appeared during construction, and that failure became incredibly valuable for archaeology. Because it preserved evidence of how the Egyptians actually worked stone. Researchers discovered marks left by pounding stones, hard dolerite balls used to chip away at granite gradually over time. Rather than slicing through stone instantly, workers shaped it through repeated impact. This required enormous labor, precision, and planning. The process was slow, but it worked. Archaeologists have recreated similar methods experimentally and demonstrated that ancient workers could indeed shape granite using stone pounders, abrasives, and copper tools. This is important because Egyptian engineering was not based on impossible technology. It was based on persistence, organization, and accumulated knowledge. The tool question. One of the biggest misconceptions about ancient Egypt is that copper tools were too soft to shape hard stone. At first glance, that seems reasonable. Granite is harder than copper, so how could copper tools cut granite? The answer lies in abrasives. Ancient Egyptian craftsmen likely combined copper tools with quartz sand and other abrasive materials. Instead of the copper doing all the cutting, the abrasive particles performed much of the grinding. Think of it less like slicing and more like controlled erosion. Experimental archaeology has shown that this method can produce surprisingly accurate cuts. But accuracy alone is not the full story. Consistency is what truly stands out. At many sites, stones were shaped with repeated precision across entire structures. This suggests skilled labor specialization, careful measurement systems, and long-term architectural planning. The Egyptians were not improvising randomly. They were following systems refined over centuries. Alignment and measurement. Perhaps most astonishing example of Egyptian precision is alignment. The Great Pyramid is aligned remarkably close to true north. Even modern researchers continue debating exactly how this was achieved. Possible methods include stellar observations, solar shadows, astronomical measurements. Whatever the exact technique, it required careful observation and mathematical understanding. And alignment was not limited to pyramids. Many temples across Egypt were built with specific orientations tied to sunrise positions, religious symbolism, and seasonal cycles. The precision of these alignments demonstrate that Egyptian builders were not merely constructing monuments, they were integrating architecture with cosmology. Geometry and symbolism worked together. This required surveying knowledge, planning teams, and skilled architects. The construction process likely involved repeated measurement rather than brute force alone. Moving massive stones. Another major question concerns transportation. How were stones weighing dozens or hundreds of tons moved across Egypt? The answer again appears to involve organization more than mystery. Archaeological evidence suggests that workers used sledges, rollers in some cases, lubricated sand, ramps, and river transport along the Nile. Ancient wall paintings even depict workers pouring water in front of sledges. Modern experiments show this reduces friction significantly. Large projects would have required labor coordination, supply systems, food distribution, and skilled supervision. Recent discoveries near Giza, including worker settlements and administrative records, reveal that pyramid construction involved organized labor forces rather than enslaved masses. This changes the image many people once had of pyramid building. These projects were state-organized engineering operations. The Serapeum of Saqqara. One site often discussed in conversations about Egyptian precision is the Serapeum of Saqqara. Hidden beneath the desert are enormous granite sarcophagi associated with the sacred Apis bulls. Some of these stone boxes are extraordinary. They feature smooth, polished interiors, sharp angles, massive granite lids, and tight geometric consistency. The craftsmanship is undeniably impressive. However, there is also a tendency online to exaggerate these features into claims of impossible technology. The reality is more grounded, but still remarkable. These objects likely represent the highest level of elite craftsmanship available in their period. They were created for sacred purposes and received enormous investment in labor and resources. This reflects something important about Egypt. Precision was not only practical, it was symbolic. Perfection itself carried religious meaning. Precision as a symbol of order. To truly understand Egyptian engineering, we must understand Egyptian belief. Ancient Egyptian society valued the concept of Ma'at. Ma'at represented balance, harmony, cosmic order. Architecture played a role in expressing that order. Monuments were not simply buildings, they were statements about stability and permanence. Perfectly aligned structures, precisely shaped stone, carefully ordered spaces, all reflected the Egyptian desire to impose order over chaos. This may explain why such extraordinary effort was invested into construction. Precision itself became sacred. Modern technology re-examines Egypt. Today, modern researchers continue studying Egyptian engineering using advanced tools. These include laser scanning, 3D mapping, muon tomography, and material analysis. These technologies help archaeologists measure structures more accurately than ever before. And interestingly, many modern studies continue confirming just how sophisticated Egyptian engineering really was. For example, scans of pyramid interiors reveal highly planned internal structures. Stone analysis reveals consistent shaping techniques. And digital modeling helps researchers understand how weight and pressure were distributed inside monuments. None of this requires rewriting history, but it does require appreciating ancient skill more seriously. What the evidence actually says. One of the biggest problems in discussions about Egypt is the false choice people often make. Some claim the Egyptians could never have done this. Others dismiss every question entirely. But the evidence points somewhere in the middle. The Egyptians absolutely possessed the ability to create astonishing precision,